Hi, I'm Angus at LabVac. Today on the bench, an Edwards E2M2 vacuum pump, which we're going to have a look through and take to pieces. This one is out of my private stock, collected over years and stored in a container over there. I've been asked to make videos on the EM range. I started this morning taking apart an E2M2, so there'll be a video coming on that, and you might be able to see it in the background on the bench next to me. I've just shifted all of that over there, and I'm now going to dismantle this E2M2. So this is the smallest of the range. There is a 2, 5, 8, 12, 18, 28, and then very different pumps, but there's then a 40, an 80, 175 and a 275, so going up to really high flow rates. 275 referring to the cubic metre per hour displacement. This is a 2, so this is the smallest. There are then single and two-stage versions, so you'll have an E1M5 and an E2M5. The E1 is a single stage, the E2 is a two-stage. The 2 was only available as a two-stage, so there's no E1M2, there's only E2M2s. So with that little bit of history behind us, let's do some work. These pumps all have plastic side flashes, we call them, side panels that sit over the coupling. So I'm going to start by taking those off from both sides. I am trying to get a bit better at not sticking my baldy head between the camera and the pump. Apologies when I do that, it's purely because I need to lean over to see what's going on and I forget that I'm supposed to be recording it for posterity. I'm learning as I go along with all of this. So side panels out of the way. The next thing we want to do is get rid of the electric motor. Caution, the coupling on these small EM pumps is a bonded rubber coupling with a fan. It's all one piece, and they tend to stick to the shaft of the pump. And so if I just undo the 4 bolts and pull on the motor, it's not going to come up, not going to come apart. There is a key with a grub screw which holds the coupling onto the shaft. So I'm going to turn the pump by hand just by pressing on the fan blades, which I can now access where I've removed the side panels. Turning and turning and turning, and looking for the grub screw. I must have gone all the way around by now, so where is it? There. And I go in there with a long 3mm Allen key, and if the gods are shining on me, yeah, I get into that, hopefully get it undone. There we go. God, the kickback on these long Allen keys can be nasty. So there's the grub screw out. It's only gripping on the shaft, it doesn't have to come all the way out. I prefer to take it all the way out so I know where it is. What I don't want is for it to fall out if it's only for at some other point. So the coupling is now detached from the shaft. So I can now go and take out the motor bolts, of which there are 4. But the coupling may still be very tight on the shaft, and so the danger is that I start wellying on it with a hammer to get it to come free, because I've undone everything that should be holding it, but it still won't come. So brutal force would be the normal next choice. But what will happen is the rubber part of the coupling will stretch and eventually tear. And this is an old pump. This is not a production model and hasn't been for decades. And so while spare parts are available, buying a new bonded coupling is expensive, very expensive. So what I do instead is to go in with a couple of screwdrivers and get in behind the coupling, push the coupling with the motor as it comes off. So I'll try and give you an idea of where we're going. It'll be easier to see once we're taking it out, but you need to get in right down there behind the coupling. So that it's not tearing as it comes apart. It's tricky to do, but it is worth caution. Sorry, I'm immediately sticking my head in the way. And I can just look at it as it comes apart and see that yes, that is moving off the pump shaft, which is what I want to see. I haven't checked whether I've drained the oil out of this pump actually. It literally comes straight out of the container and onto the bench. There we go, now I'm behind it. Okay, so with the motor off, you can see that the pump shaft comes in here. The grub screw sits in that hole there at the side, and this is the rubberized part. This is all one assembly. So what I was doing was putting the screwdriver in behind there, or even into that slot, and levering gently against the pump, so that this whole assembly comes off rather than the motor end coming off, leaving this torn coupling in there. So that's the motor removed. Obviously, good time to check it. You can run the motor without the pump attached, make sure that the motor sounds good and is working well. Doesn't appear to be any oil in here. Let's just be certain of that. I'm on this special bench with a drain here that drains into a bucket underneath. So if any oil does spill at this point, it's not a problem for me. I've got a high lip around the edge and I can push it down that drain hole. Right, so that's the drain plug out, nothing's coming out, so there's no oil in this pump. I also want to take this extension off. That's not a standard part, that is something that's been added evidently where this pump was being used. It was helpful to have a little extension on there. It's not helpful for what I want to do, which is to stand the pump up on its end. So there we go, let's get that out of the way. So yeah, you can now stand the pump up on its end, get this base plate out of the way, which will make it easier going forward. I don't really know the history of this pump. I would have done at the time that I received it, but like I say, I've got a large stock of pumps waiting for refurb that are not customers' pumps, they're just ones that I've inherited, or taken in, trade-in or whatever. So I haven't looked it up and tracked the serial number or anything like that. Just just plunging in. If there's anything smelly or it starts to look nasty, then I'll put some gloves on and take some precautions. But for the time being, I think we're okay. Next thing off then is the red plastic cover that holds the felt pad. Felt pad is there to hide the fact that your pump is leaking and needs to be serviced. It soaks up the oil that drains out of the shaft seal. Not a fan. I think if the pump's leaking you ought to know about it, but that's the felt pad. It's absolutely saturated with oil, so this pump's had a good old shaft seal leak. So I'm going to next take the key out of the shaft. That's the key that holds the coupling. And that's it. And if you look at the E2M2 video, I guess these will both come out roughly the same time since I'm working on them both on the same day. On the E2M2, the oil pump is located on the rear of the adapter on the outside. On the 258 and 12, it's internal. So there's nothing else to do here until we get inside the pump. So we can now turn it over, and this is the fun bit. I can see a little bit of oil accumulated there. We're going to go in here with a 5mm Allen key and take the oil box bolts out, get a first look inside. I haven't cheated on this one. I don't know what's inside here. No idea of the condition of the pump. I haven't looked in advance. It's going to be a mystery we'll solve together. Right, so bolts are out. And the oil box lifts off straight away. Wow! Normally they're very stuck. If it's very stuck, take a rubber mallet, tap it around the bolt locations, and eventually it will come free. When I say tap it, I don't mean tap it like I just did there, I mean welly on it. Not hard enough to break the castings obviously, but enough to get inside. So sealing those together was this cork gasket, which is completely destroyed, as you can see, which is why it came off so easily. Some of it's stuck on the oil box, some of it's stuck on the adapter. That will all need to be removed obviously. The easiest way to do that is to take a sharp blade. In the UK we call them Stanley knives. Don't know how that translates. Just work underneath it until you can lift the cork away. You don't want to put scratches into the surfaces, so you need to take your time and work cautiously, but by doing that you can go all the way around and get rid of all the little bits of cork gasket that are stuck behind, and then clean up those surfaces with some Scotch-Brite or something similar. So here we are with the internals of the E2M2. The E2M2 5, 8, I can see problems with this already. 2, 5, 8 and 12 are very, very similar inside. The 2, 5 and 8, the difference is only in the high vac stator, which will be longer. So this is the 2, this is the smallest, the 5 will be there, the 8 will be there. The 12 again is slightly different. There are a few subtle differences with the 12 from the others. The rest of the architecture is identical. So if you've seen this one, that covers you for a number of different models. If it was a single stage pump, it just wouldn't have the second stage. So this is our first stage, high back stage. This is our second stage, the low back stage. One of those would be missing if you had an E2M2 something. So I can already see that's the exhaust valve, which is loose and flying around because the component that should be holding it in place, the clamp that holds it down, is not here. So at some point, someone's come in there, taken that away. It might have been me. I might have at some point years ago needed that for another pump and borrowed it. So we'll take away what we have got. So the first thing is a copper pipe here, which is a gas ballast. It lets air from this gas ballast control down through this pipe and into the pump. So there's a clamp over one end of it. So that clamp comes off, and now this pipe should be able to be pulled out from both ends. And it has. You often need to go behind that with a small screwdriver and give it a tap just to encourage it. But this pump is coming apart surprisingly easily. There we go. So this end doesn't have a clamp. On here you can see there's a brass end to the pipe, and then on that there's an O-ring. So it's the O-ring that seals into the holes on both ends, and it's the O-ring that was holding it tight in there, so it was the tension on the O-ring that had to be released to pull that out. Okay, so this is what we call the cartridge. This is the adapter. What we'd like to do at this stage is to separate the two from each other. So we've got 3 bolts holding them together, which I'll crack off there, and there, and one over here. Take those out. And the cartridge good. There we go. Come off there. We've got a few spring washers to gather up as we go. So this is the adapter plate, as it's called. This is where your gas ballast and your pump inlet are. So the air flows down here through this hole, which marries up with the hole into the pump mechanism. And that O-ring would normally be sitting there sealing between the two. And this is what we call a cartridge. So this is the entire pump mechanism as one assembly. This is what we need to take apart. You can go about it in different ways. These videos are not a sort of one and final discussion on how to tackle the pump. You can go about taking it apart in different ways. I don't do it the same every time. I tend to go for the easy bits first. I'm going to start by taking this distributor off. This distributor is what controls the oil flow through the pump. So it controls the pressure of the oil circulating in the pump. It's able to release any excess pressure, and it also prevents oil sucking back when the pump's turned off. So we have a long bolt through the middle with a washer and a spring, and there's a cover which is literally just the cover. Those weren't on the very early pumps. You've got a very early EM pump. It doesn't have that cover or this extra spring. So this is the second spring. It's referred to by Edwards as a wave washer. But it acts as a spring. Then we have a backing plate. And then we have this rubber diaphragm, which is the one that's doing the work. It sits on this piston, which you can remove the piston from it. And it's this rubber diaphragm that controls the flow of the oil. So oil is forced up underneath by the oil pump, and when there's sufficient pressure, it will lift the diaphragm against the wave washer, lift it and allow oil to then flow over the ridges and down through the other oilways, passages throughout the pump. And then this body is just sitting on there. There's a couple of pins that locate into here, and then the oil coming up and going back down is through those holes there. So it's a fairly simple device. There are a few little variations on it. It's in all of the EM pumps right the way up to the largest models, but it didn't transfer over into the RV pump that came after this, so you pretty much only see it here. Now there are a couple of O-rings that seal that distributor body under there, so those want to come out. Put those to one side, and then under here we have the interstage valve. Is that a 5? Yes, that is a 5. There we go. So we'll get that undone. This is where the excess pressure is released between the two stages. So there's a steel backing plate. This is pretty well stuck. There we go. There's a steel backing plate which sits under there, and then that's the actual rubber valve. Now these vary. This is specific to the 2, this size and shape. The other pumps in the range, the 5 and the 8, use a slightly different shaped and larger size. Obviously they're higher flow, so they have more exhaust valve holes here that let that flow out. So when we come to put it back together, we look at a standard kit. The kit covers a range of different models, as most pump kits do. So you always have bits left over. You'll have multiples of some parts that are slightly different. You've got to figure out which one. It's because the kit will cover a number of different pumps. So, you know, if it's a 2, it'll use this part. If it's a 5, it'll use the other part, and you'll have one left over redundant. What you also find with kits, while we're on the subject, is that pumps change over time. They won't necessarily change the name of the pump or how it looks from the outside, but they might make changes internally that require a different replaceable part to be added to the kit. And then again, to avoid having a plethora of different kits and having to check by serial number every time you order a kit, they'll put all the parts into the kit. So that's another reason why you might have parts left over when you finish servicing a pump. I won't say don't panic, but be able to identify which parts should have been fitted and which parts should be left over. A really good way to do that is to keep all the parts when you're taking the pump apart. This distributor rubber, this valve rubber, they're going to be replaced. I'm not going to throw them immediately into the bin, because when I come to reassemble the pump a few days later or whatever, and I've got all these parts in the kit and I don't know which one to use, I've got the old one. I can easily then compare, alright, it's that part that I need. You get me? So I've just taken the bolts out of the end plate here, so that's free to come off. That's the end plate That's our first, or actually it's our second rotor stator set. And I now need to take the bolts that hold the two stators together. Not if I go the right way, wouldn't it? When you're dismantling the pump, these bolts will feel very tight, like I'm having to use a lot of force to release these. That doesn't mean that you need to use a lot of force when you're assembling it to try and sort of match that torque load. These pumps are O-ring sealed between the surfaces, so they don't require a lot of torque. They don't need very tight bolt specs at all. Talk about that again when we come to assembling, but the reason that they're very tight now is this thing has been used for probably years since it was last serviced, and they generate a lot of heat inside the pump, and the heat causes all the bolts to become very tight. So that's the 5 bolts released from there. You should now be able to take the two stators apart. And finally we've got to a point where they aren't keen. Everything else has come off so easily. So we can use a little bit of persuasion here. Provided that you have undone all the right things, you can tap on the back end of the shaft here, and that will actually force the two to separate. What you're effectively doing is using the rotor here as a driving tool to force the other end off. If you miss a bolt, doing this can cause damage to the parts. But it's a good way to just get some force behind it, and you can see there that those are starting to separate. I'm not going to drive it like that all the way. What I'm going to do now is take a pair of thin bladed but long armed screwdrivers and just put them into the gap on either side and use them to pry the parts away from one another. So with my big bolts out of the way, you can see what's happening, and they're coming apart. Now there are dowels holding these sections together, so I'm placing the pry bars, screwdrivers, close to the dowels so that I'm putting the input force into the places where the fit is tightest. So with that released, I can take the two stators apart and the rotor comes out with it. Left behind in here are the vanes, so I'll take those out from there. That's a very hardened off O-ring, which I'll stick on the pile. High-back vanes have stayed in the rotor there, they get drawn out with it, so that's the second set of vanes. And then this is the single piece rotor that does everything. There's a single rotor, coupling goes onto this end here, turns the whole thing as one piece. So this is our high back stage, our low back stage, and then hiding in here, that's the oil pump vane. So the oil pump is also part of that single piece rotor, and the oil pump itself is buried back down in here. So that vane, when the thing is assembled, will be sitting right down there and turning back there, picking up oil and forcing it through the rest of the pump. So it's important to find that bit. Last thing we can take off there is the oil strainer. This is a fairly coarse device for straining any sediment out of the oil before it's picked up from the sump and circulated through the pump. So there are our major components, all separated out. So what you then need to do is go through and take out all the seals. Quite a few of them fell out as we went along, there's a few still in there. So lift that O-ring out. There would be one there which is stuck on the corresponding surface. It's very stuck. In fact, it's hardened off to the point where it's actually just breaking up into pieces. So I was going to show you where that sits, but I don't know if you can see that on my hands. It's just broken pieces of what feels like hard plastic but would once have been soft rubber. That would have been sitting in the recess there, sealing between those two parts. So once we've gone through and taken all the O-rings off there, everything goes off and gets thoroughly washed and cleaned. The adapter plate, the inlet needs to come off. That's the inlet port to the pump. So that needs to be undone. These can be very, very tight. Screws in there on a 3/4 BSP parallel thread, so that comes out because there's a seal under there which again is hardened off. That needs to be replaced. There is an inlet strainer underneath here which is held in place by a circlip. At least it's called a circlip in the UK. Maybe you call it something else. If I can get it to come out, I'll show you and you can advise me in the comments. So there we go, that's just a compression circlip there. So those circlip pliers go into the two holes and allow you to squeeze it shut to get it out, and then with my pliers I can reach in there and lift out the inlet strainer, which is super clean on this pump, which suggests this pump's led a fairly easy life. And then there is the gas ballast control on here, which we also want to take off. And that feels like it's never been undone in its life. So whoever owned this pump didn't use gas ballast. There we go. Now on these EM pumps, the gas ballast is this rotary knob, which appears to suggest that you have infinitely variable gas ballast, which is not true at all. Effectively, as you unwind this, you'll get to a point where the pump suddenly starts to make more noise. That's the on position, and when you wind it shut and it stops making the noise, that's the off position. It's literally just on or off. But underneath here is a very long spring. That's the control. There's a ring of felt round there which filters the air coming in to the gas ballast. And there's a very long spring. Underneath that spring there is a ball bearing which acts as a spring seat. That's all it does. That's all it's there for. But it does need to be in there, because if it's not, the spring will bond into the bottom of the hole and break up. That should have been an O-ring. It's been compressed completely flat, but that's the O-ring that allows that rotating knob to seal off and close. So is the ball bearing going to come out? No. They very rarely do. They tend to be either rusted or gunged into the bottom of the hole. If it won't come out at all, then it's not the end of the world, because like I say, it's literally there just to act as a seat to the bottom of that spring. But what often happens is you go to a parts washer or whatever to start cleaning the pump up, and ball bearing falls out and disappears and gets lost, never to be seen again. So I like to just put some solvent down there, which is what was in the spray can, poke around with a scribe, and eventually that ball bearing will fall out. So that's what it is, and the spring sits on top of it, and it just stops the spring from collapsing and breaking in the bottom. So you want to try and get that out. If it won't come out at all, like I say, it doesn't matter, you can rebuild the pump without worrying too much about that, provided it's in there. And that's everything removed from the adapter plate except for that outer shaft seal. So to remove the outer shaft seal from these pumps, there is a circlip again around the back of here. You don't really need to remove that. What you can do is lay this face down, take a punch, or any similar tool, and a dead blow hammer, just knock it through from the back. It's a nice big seal, these old seals, with lots of surface that you can get at, so it's one of the easier ones to remove. Just punch it down like that. You'll destroy the seal, but it doesn't matter, we're going to replace it. So that comes out of there fairly easily. The inner shaft seal is trickier. Okay, so we've got a couple of O-rings again on that. If you do go and watch the E2M2 video, I don't do all of this in that video, it's shorter. I don't go through removing every single O-ring and so on, because the process is the same. The purpose was to show the differences really between the small EMs and the larger EM pumps. Once you get to the 28, which I haven't done a video on yet, but I will, that has roller bearings inside it and so on, and it starts to become a much more complicated job. But that's those components there. The final thing is to get this inner shaft seal. So this is a component that was sitting there, and it has a seal inside it. With the two, it's relatively easy because this is a short stator, not very deep. The seal's right here, but you can imagine on the larger models, it's a long way down through the stator to actually reach that. The most useful tool, my first choice anyway, is it's called a split collet puller, and the way this works is as you wind these two parts together, a pin down the middle, a conical pin down the middle, forces the collet to open up. So you put this down through the seal you want to remove, wind the two parts till it opens up. You need to put a fair amount of effort into this. So I use, in the UK we call these water pump pliers. I think, correct me if I'm wrong, I think in the US we call them channel locks. I'm sure they have plenty of different names, but they're big pliers, you might say. And then a big spanner to open that up, and I want to go as far as I can with that to make sure that I've gone as tight behind that seal as possible. So that's now fitted behind the seal, and then I've got a slide hammer, screws into the top. And that's pulled straight out through the seal. It doesn't always work. Like I said, it's my chosen tool. Doesn't necessarily mean that it's always going to do the job. I have various different sets of these. But to show you an alternative method, sometimes a seal like this one is in so tight and it's been there for so long that the tool is going to destroy the seal and pull out of the seal before the seal actually releases. So the alternative, which I prefer not to use, but in this instance I'll show you what I do, is to take a very small screwdriver, and this has been ground, the sharp edges have been ground off it, and then you just want to sit that in between the seal and the metal and drive it down between the two. This seal is really solidly in there. Can't even get the lay this into it. But the idea is that you get behind the seal like that, and then by rotating the screwdriver you can dig the seal out. And the seal will gradually fold up on itself like that. Hopefully you can see that starting to happen, and then you can work your way around. The reason I don't really like to do it this way is obviously you're prying with a lot of force against the metal surface of the pump, which is the part that you want to retain. Doesn't matter about the seal, and it's got it out by completely destroying it and bending it up. That's what you need to do to get that seal out if it won't come out in a more conventional way. But obviously what you're trying to avoid is gouging into the metal here. I mean, I don't know whether the camera can see it, but I can see it has left a mark where the screwdriver has done that. That now needs to be repaired. So I'm going to need to go in there and just hone off the marks where the screwdriver has gouged a little bit into the metalwork. So the right tool is better, but it doesn't always work and you don't always have it. So there we go, that is everything out. So all this stuff needs to get very, very thoroughly cleaned, and then we'll come back and just look at some tips on reassembly. Okay, so here we are ready to rebuild this E2M2 pump we've been looking at. I have found the missing component I mentioned earlier on, which is this retainer and screw for the vacuum valve. So that's a replacement part that I just happened to have that we needed, and I have also got the baffle which was missing from this pump, which sits across the top, so we'll get that installed at the same time and everything will be back how it should be. Here's my kit. Kits come in various formats. This is all separately bagged, so I've got a cork gasket for the oil box. I've got a bag of metal parts including my various replacement springs and so on. I've got an inner shaft seal which for some reason has got a bag to itself, and the outer shaft seal is in this bag with the O-rings. As we go through this you'll see there's quite a lot of parts left over because this kit covers The E1 and 2, so single stage and two stage versions of the 2, 5 and 8 pumps. They don't all have identical components inside, so there will be some leftovers. Then I've got a new felt pad and a new felt for the gas ballast silencing and filtering. In terms of the rebuild, the first part I want on my bench is the adapter. I'm not going to populate this with any parts at the moment. I'm just using it as a stand, because if I take the stator, which is my first main component, and I want to fit the rotor into it, it won't go in because there's no clearance underneath. But the adapter is exactly the right part to lift that up. That's it. There we go. Right, this has been left overnight. There's a little bit of surface flash rusting that's happened there. This is very minor. This part is clean. This has this little bit of flash rusting on here, which I'm just going to take off with a bit of fine Scotch-Brite. Normally you want to be doing the cleaning and then reassembling the pump immediately, but I have to go home at nights occasionally. And that little bit of flash rusting won't have done any harm at all, just on the surface there. And then I need to be certain that all of that Scotch-Brite dust is out of there, which I can do with a bit of compressed air. Compressed air is your friend with doing any work on these pumps. I certainly wouldn't want to be without it. If I have to work on site, there are canned air dusters and things like that that you can get. It's never the same as having a proper compressed air system. So I need to start by putting the inner shaft seal into here. And that sits in this recess there. So I'm just going to locate it and then dig under the bench. With the right set of seal drivers, I use simple seal driver set. I'll go initially for an oversized seal driver that's bigger than the seal, and I want to drive that down until the seal driver sits flat on the metal surface of the pump. That way I know that it's gone in straight and true, and then I'll use a smaller seal driver to pop it down the rest of the way. I've got a lot of different things going on different benches in here at the moment, but I can't drive the seals on this bench because all the other parts go flying around. So I'm moving across to a nice stable bench right over the leg of the bench where it's solid. Make sure that that is level, and then drive it down with a hefty blow. And you hear the sound change once the driver is sitting flat on the metal surface. And I'll pop that size out and move down to the correct size to fully seat it down. all the way into there. So my seal is installed. Just to make sure that that has gone all the way home, I'm going to very carefully drop the rotor into it, and what I should see is that the rotor and stator are exactly flush when that's pushed home. If the seal hasn't gone all the way home, then the rotor will end up sitting up like this. If you've got a gap there, then go back and redo the seal. Do get a little bit of debris come off when you're driving that in. You can sometimes get a burr or something come up from the side, so just clean that out. And the next thing to go in is going to be the rotor. Now, building up these pumps, you need to lubricate everything thoroughly as you go. Fill a jug with vacuum pump oil, so I can use that to lubricate things to put together. No, I'm not going to use all of that in lubricating and build up, but anything that's not used obviously can then be used to fill the pump when it's built. So, rotor goes in next. It's going to go through that shaft seal. We're only looking at the inner at the moment. That runs on this section here, which is good and clean. There is a mark you can see where the shaft seal has been running in the past. I'll just check that and make sure, yeah, there's no groove there, so it's not worn. Very important at this point with these EM pumps is to remember your oil pump vane. You'll remember from disassembly that the oil pump is behind that shaft seal, down low in the pump. If you forget to put the seal in at the blade in at this point, then it's a complete strip down again to get to it. So out of that little pot of clean parts, that's my oil pump vane blade, interchangeable words. You can install that the wrong way round. Hopefully you're able to see I've deliberately put that in the wrong way round with the curvature in the wrong direction. The curvature has to follow the rotor, so when it's incorrectly and you let it drop through, you'll see that you get a smooth finish. So tip number one, make sure it's the right way around. A little bit of oil onto there. That's my oil blade installed. Now while I'm handling this, you don't want that to fall out. That's as bad as forgetting to put it there in the first place. The oil, obviously the surface tension of the oil will help to hold it in place. Next I take the vanes. The vanes in the two stages of this pump are not the same, so I'll make sure that I've got the correct ones. And these get a pin and a spring in between them to keep them forced out onto the stator wall. So into my next bag, which is metal parts, springs and so on. That's a vane spring, and the vane spring in the EM pump sits on these on pins. There's one pin that goes in, makes no difference which way round it goes, and that sits into the hole. So I'll put those two vanes together. Oil again, feed that into the rotor. All of this has to be done before you put the rotor into the pump. And then you've got to get all of that into there. And the oil pump vane can be a bit stubborn about sitting down into position. So I'm making sure that I'm going very slowly and carefully, and I'm rotating that in the direction it's going to run, and eventually it just sits down, the oil blade goes into position, and I'm back to having that flush setting. If the oil pump vane doesn't sit in, you won't get that back to flush position. Let's give that a few turns, make sure everything is running smoothly. Then I want to get a bit more lubricant in there, so I can just pour some oil in. Make sure that's gone all the way around. Okay, next up we need to start putting the O-ring seals into the pump as we go. So another bag, this time of rubber parts, of which you can see there are very many. This is where it's useful to be able to refer back to the parts you took out to see which ones you're going to use. So I've got 3 different distributor rubbers in this kit. I've got 2 different exhaust valves. We'll see all of those as we go along, identify which ones we need, put the rest to the other side. So the largest of the O-rings sits into that groove around there. And once it's in, that'll stay in there fairly well. No other recesses on this part. Shouldn't need to put anything else into there. And I can move on to the next component, which is this centre bearing, I refer to it, where the rotor passes through here. It's not a roller bearing obviously, but it effectively works as a bearing. It's a close tolerance through there. There'll be a film of oil in there once it's all lubricated up, and it's acting as a bearing to keep the pump stable. So I'm going to go and apply still more vacuum oil, pour it in there fairly liberally. I mean absolutely everywhere, but obviously anything that is not consumed by the pump will just get exhausted out. So I want to make sure all of those surfaces that I'm working on are well lubricated. I'm going to do the same here, just run some oil round that centre bearing, and for good measure a thin film across the mating surfaces. This will all be done by the oil pump once the pump is running, but if you start the pump up dry, you'll have metal on metal or metal on vane or whatever, and you can do a fair amount of wear and tear damage fairly quickly if there's no lubrication in there to start with. So that section sits over there. This has dowel pins in it, so as I gently lower it on there, you can turn it until it hits those pins. They won't go down easily. They're tight obviously for a reason, so then I can just push that home. I know it's all lined up because the dowel pins are there. These pumps don't need to be hand set. They are what they are. And then to fully close that, I can use the through bolts. So all the bolts I took out have all been cleaned. They've had the heads across the wire wheel just to make sure that they're completely clean. And I lay them all out. I've chucked everything into one pot, you see, so what I have is different size bolts all mixed in together. I'm going to separate those out into sizes, and then I need 5 of those to go into here to close these 2 components together. If you're unsure of what goes where, figure out a method that you can use more pots and keep them separate if you need to. sufficiently familiar with these pumps, I should be able to figure out what came out of where. Done this many times. And then what I'm doing is just winding those bolts down. I'm moving around the pump, just putting a bit of tension on each one and then moving on so that it draws the two stators together evenly, and it's drawing them down onto those dowel pins. Eventually I'll get to a point where all 5 of my bolts are all the way home. There's no more movement to be had on them. Okay, they're getting tight now. Don't need a lot of force on these. You can see I'm only using hand tools. I never use any power tools, either dismantling or assembling pumps. In a lot of cases, you've got maybe steel or stainless steel fasteners going into aluminium threads. It's very easy to cross-thread something, ruin the thread, and then the pump is potentially worthless because it becomes uneconomical to do the repair then. So I know I'm all the way down here. The bolts are all tight. Again, I'm flush here. Rotor and stator ends are flush, and then I can pick the pump up, and I can see that the gap's properly closed. Everything looks good there. What I like to do is turn the pump by hand while I'm at each stage of building it up. Turn it by hand in the direction it will turn when the pump's running, and then that excess oil, hopefully you can see, just being forced out of these valve holes. So I know that that's operating. It feels smooth. There's no point, as I turn it, there's no point where it snags up or becomes difficult. So at this stage I'm happy that that is in good shape. Put it back down again, and I need to get the 2 vanes installed in the second stage. Now these vanes have 2 holes in them, so I need 2 springs and 2 pins. Pins go through the springs into the vane. I alter the way round, so if this has got the pin on the upper side there, I'll put the other pin on the lower side. I don't think it really makes any difference. It's just something that I like to do. So those are ready. Now these can be slotted because there is a full gap across the rotor here. I can just dip those in some oil, compress them together against the springs, and drop them both at the same time into there, feeling that they go in smoothly and that everything is looking good there. Then I just want to give the pump another turn. I've installed another part, so I want to make sure that it's still freely turning. The more components you put in here, the harder it gets to turn this shaft by hand. There you can see again, I've got some oil coming up through my exhaust valve. I've got some oil coming out the front end. Everything's looking good, feels okay. Now, it is difficult to turn that pump by hand. If you remember, early on I said that the couplings can get damaged. What I've got here is the basic rubber coupling that's used on these pumps. It's the one we took off. The one we took off is still attached to the motor, and it has a fan on here as well. This is the basic coupling removed. I just keep one of these handy so that I've got something to turn it with while I'm working on it. So what I need to do stand it up again on its side, find the keyway and slot the key into the shaft, and then I can slide this spare coupling on. Just enough that I can then use it as a handle to turn the pump. It just makes it a little bit easier. You do have to keep removing it every time you lay the pump back down again. But if you get a broken coupling at some point, hang on to it. That's what it's useful for. So, next part of assembly, got two recesses here. So I've got two O-rings to go in. That one fits in there, and then there's a very small O-ring that sits down there. We'll just seal that oil way against the end plate. My end plate is here, all cleaned up, and that sits on the end. So I've got these are the longer of those bolts. I'm just putting the two lower ones in at this stage. There's two more that go into those holes. Nip those two up. The reason I'm not putting the upper two in at this stage is because the upper two also hold this plate, so that plate sits there. So rather than put them in and have to take them out again, the two at the bottom is enough to hold everything together at this point. So with all of the major components fitted, I'm going to again just check by turning that. There's oil coming up through both of the valve ports there, which tells me that the vanes are moving correctly. That's enough for now. I'm feeling again, are there any tight spots when I turn it? Anything that doesn't seem to be correct, you can go back in and fix. So, move my adapter out of the way. We don't need that now. I'm going to keep the pump this way up for the time being. And I'm going to populate the top of the pump. There are various things that need to go into here. So the first is the intermediate valve, of which I have two rubber plates in the kit. One is obviously too big, that's for a different pump. Put that to one side, and that's the correct size, that's the one that's going to go in there. So to assemble that, I use the same parts that I took out of it. There's the metal cover plate that goes there, and there's this stepped washer, and the stepped washer goes downwards through the rubber, through the hole in the rubber. And what that does is it just prevents you from over tightening it and crushing the rubber in there. Okay, so that's how that assembles. So that'll go through the outer retention plate, through the rubber, and then line it up with that hole. Just drive that home. It's a good idea to just hold those components still while you bring that down. So we'll try to move obviously with the torque of the Allen key. I'd like them to stay straight. Because we've previously assembled the end stop here, they won't be able to go too far out of whack. Not a huge amount of force on there, just snug it up. That's the interstage valve. Into here we have the final exhaust valve, which is this rubber poppet. Sometimes it's referred to as a bullet, and then that has a spring sits on top. And then the part that was missing from this pump when I took it apart is this valve holder that again sits down into the spring like that. And then that whole assembly screws down into the holes that are there. It has dowel pegs built into it. So again, the alignment will be good. Valve sits in there. Make sure that that post slots in properly. And then push that down by hand, making sure it locates into the two holes for the dowels that are in there. And then the screw will tighten off into there. So we're looking good. We've got two parts into there. I'm not entirely happy with the way that interstage valve is looking. Okay. Yeah, I think that looks better. It looks slightly better aligned now. So that's those components. Our distributor is going to sit onto here. So all my distributor components are there. There's the piston that sits through the middle of it. And then I've got a new wave washer. That's our crinkle cut wave washer that sits on there. Now I need a distributor rubber. Like I say, there are 3 in here. Normally there are only 2. I'm not sure why we've got 3 here. I put one to one side because those 2 are the same. Hopefully you can see there the major difference here. They're the same diameter. The major difference is the size of the hole in the centre. The distributor changed at some point through the years. Continuous improvement. So the component that goes into there is the piston. So what I'm going to do is just select the rubber that best fits the end of the piston. The large hole is too loose on the piston. Okay, so that can go to one side, and on this one it's a small hole that I need. See, that's a snug fit there. So that's the component that I'm going to use. The other one is for a different pump. Again, I've got 2 recessed holes here, so I need O-rings to go into those. These are a tight fit. You really need to make sure that you push those home. Otherwise, it won't sit correctly. Then the base of the distributor, again, dowel pins fit into the 2 blind holes there. Bit tricky to get those aligned today, don't know why. There we go. That sits over there. The distributor rubber goes in next. That sits there. And then the piston snugged into that centre hole. Pressure plate sits over that, sits all the way over and over the piston. The waved washer sits onto the shoulder on there, and then the cover goes across the top of all of those, like that. Then we have our long bolt through the middle, which gets a new spring. Spring sits over there, and the bolt and the washer go on top. Hopefully, because of those dowel pins underneath, that will be lined up with a hole. I'm going to use my finger and thumb to compress the spring so that the screw's free, and then yeah, that's screwed in there nicely. And just wind that down, tension it up. The assembly itself sets where that spring compresses to. So that's driven home, that's the distributor rebuilt. And the final hole we've got here is the gas ballast. So that's where this copper pipe sits in. Okay. Now underneath there is a non-return device to stop oil being sucked back up the gas ballast pipe when the gas ballast is turned off. Again, in the kit, there are two different ones. The removed parts are over there, you can compare. I know that the star-shaped one is for the 5 and 8 pumps, so I'll move that out of the way. This is what we use in the E2M2. And I use some tweezers to drop it into the hole, just to make sure it goes down flat. Check that that's sitting flat in the bottom of the hole, and then that will be retained by the pipe when that goes in. I've taken the old O-rings out of here, so I've got to fit new ones to it, which I've got in the kit. These are the toughest ones to get into place. You really have to stretch them across the top of the brass end, and then they'll drop down like that into their grooves. And then I'm going to oil each of them. You'll have noticed that I've had a little finger damage yesterday. Got not so nice looking plaster. Holding that all together. Just take that stray bit of fluff off there. Okay, so the tube fits that way round. I've lubricated that O-ring so it should push in fairly easily. There you go, goes in with a snap. Now, the pipe is very easily bendable, okay, and we're going to need to bend it a little bit to get it to line up with the hole in the adapter when we assemble this into the adapter, but for now, that's there. And that's the clamp that came off there. The clamp sits over there and screws down thusly. Stops it popping out. And that's the adapter built. Sorry, that's the cartridge built. Now, at this point, I'm going to take the key out of there, put it over to the side, move the adapter out of the way, quick clean of the bench, turn my attention to the adapter. There's various things that need to be assembled onto here. The gas ballast pipe is going to go into here. The O-ring's already assembled onto it, so there's nothing else to do there. There's two obvious grooves which take O-rings, so I can apply those now. One there and one where the pump inlet comes through. Okay. There are also the components for the inlet and the gas ballast. Do those now, or you can do those after it's assembled. I'm going to go ahead and assemble the cartridge to the adapter at this point. So I know I've got 3 screws here, which is how they're held in. Got 3 washers, and looky here, got 3 screws left over from that pile I started with. So I'll prepare those. And the other thing that I have to prepare in here is the outer shaft seal. So the outer shaft seal is this large one. In terms of orientation, the channel, the recessed inner channel, is, as the name suggests, the inner surface. So with the pump running, there's going to be oil pressure onto here, on the oil side of it, and that increases the tension and makes the seal good. So if the oil is going to be on this side, then the shaft seal needs to be installed that way round. The tricky thing here is that I haven't got that big space to apply apply force to put this in, so it's got to be done a little bit more gently. We've still on here got the circlip fitted, and that seal needs to come all the way down until the rear of it is sitting on that circlip. So I can start it by hand to get it level, and I'm going to get that as level as I can by hand, and then I'm going to take a seal driver, which I put up here, and I'm going to drive the seal down. I've got a very small amount of material around the outside of this for the seal driver to sit on, so it's very important to go carefully and make sure that that goes down without nicking it or pushing it in any other direction. And again, use my solid bit of bench over here. Make sure that that seal driver is accurately positioned, and then drive it down until it's absolutely solid. So I've driven that down with the seal driver, and I can flip this over. I'm just going to eyeball the back here and make sure that it's sitting against the circlip all the way round, so it's not cocked to one side. That's the outer shaft seal in place. So that's all the components that I need to fit to this before I can put the cartridge into it. I'm going to take a drop of oil on my finger and run it round the inside of the shaft seal so that I've got lubrication when this part of the shaft goes in. There's kind of a chamfered edge here, which also helps for that to drop through without damaging the seal. I'm going to lower that assembly with the shaft going through into the correct position. You can also at this point see the holes. You can see through the cartridge to the holes that it's going to line up with. So I know I'm going in the right direction, but I've still got to get this gas ballast pipe to line up with the hole that it goes into. Okay, so I can't push it all the way down until that is lined up. So there we go. Now I've got to get the pipe into position where it will drop into the hole. Easiest way to do that is brute force. What I'm going to do is use a screwdriver and a little bit of force just to drop that into place. Okay, so I've now got those components there. I know the gas ballast is in the correct position, so the pipe has bent itself around a little bit to do that. 3 bolts that hold that together. Those need to go in now. Just like everything else, I'm going to tension these a little at a time all the way around so that it draws together. I'm going to start by getting each one just on a few turns, just so I know that they're lined up correctly. I've just switched to a ball-ended Allen key because I need to come in at an angle. That's it. And once they're all going down, I can go round bit by bit and tighten them down. They'll get to a point where they naturally stop. Now I'm just going to knit them round. I'm only using the short end there to apply pressure. I'm not going to go in and really welly down on these. The pump is O-ring sealed all the way through. Where there needs to be a seal, there's an O-ring. so I'm not really putting a lot of tension on to the bolts. Like I said, when the bolts came out they were very tight, but that's because of the years of running at high temperature. And these are a case where you've got steel bolts going into the aluminium adapter. Put too much force onto those and you just pull the threads out of the aluminium, and then the pump is probably not economical to finish rebuilding then. So that's the adapter built, the cartridge built up, and the two put together. Ever the cautious boy, I'm going to put the key back in the shaft and just slide the coupling on there. Give it a few turns. Now with the valves in place you can start to hear the valves popping. I can still see oil being forced through. No tight spots, everything seems to be good. There's one final part we took off that needs to go back in here, which is the oil strainer. I've got a new one in my kit. So this fine filter oil strainer. Oh look, and I've never seen that before. So I packed the kit, put a piece of paper shoved in the middle there. Obviously it stops this from being crushed in the box, but I'm glad I spotted that before I installed it, because it wouldn't have been too helpful. Now this sits on a square seal. It looks like an O-ring from a distance, but it's actually square sectioned. That sits into the recess down here. Again, bit of a tight fit, take your time, make sure it sits down flat. Then there is a clamp and a screw to hold that into place. So the clamp sits over the filter, screw goes in there, drops into that hole. And while that's being tightened up, you do need to hold the filter over that seal that we've just put underneath it, because the seal takes up all of that recess, so there's nothing to locate that into other than to tighten it down. Once it's down and the seal compresses, it will locate itself. So we'll finish that off. So the final thing to go on then is the baffle. It sits up here and the two remaining screws go down to there, tightening the end plate and holding the baffle in place. You do want to be careful to make sure that the baffle has gone over the top of the distributor screw back there. This one has done it for itself. Often you need to just push it up there while you're tightening down to make sure that it clears the top of the distributor. Nip everything up. And that's ready to get the gasket and oil box fitted. The gasket has a thicker and a thinner end to it. Logically, I've always thought the thick bit should go at the bottom, but it doesn't. The thick bit goes at the top and the thin bit goes at the bottom. Obviously the oil is sitting down onto that, so you'd think you want more cork gasket at the bottom, but it doesn't fit that way round, so it can only go the one way. See, they were pokey-okey at Edwards, even back in the 70s when this pump was made. Oil box is going to drop on top of there. The way I like to do that is to take a couple of the bolts, drop them into the holes, so those are sitting in there, and then I can eyeball the position of the cork so that I can see through to the threads. And I'll get down low, lower the oil box over the pump and watch those 2 bolts drop into the holes. It's the easiest way that I've found to just align those. And then just start them off to make sure that they're going straight into the threads easily, and then add the other 2 bolts. The top holes, same again, make sure that they're going in. That one's not, so just a little wriggle to try and bring that into line. That one hasn't gone in at this point. What I'm going to do is try and get the other one. Yeah, the other one has found its way through more easily, so in theory if 3 of the 4 are there, then the last one should, and it does. But again, if there's anything that feels off about that, these are stainless steel bolts going into aluminium threads, so if anything doesn't feel like it's running in smoothly, stop. Take the box off, check the bolts and the threads, because any damage could be game over. So then I'll just bring those down. Again, the cork gasket doesn't need masses of compression on it. I'll work my way around so it sits down evenly. Don't do one bolt all the way down hard and then go back to the other ones. Do them all bit by bit. So that everything comes together flat. So everything's hand tight. And just from experience, I've got a pretty good idea of how tight those should feel when I do them up. Okay, so the pump is starting to look like a pump again. There's a few things that I can put on. I can put the drain plug in at this point. So this plug that came in the kit is a replacement drain plug. And this uses the Doughty seal. If you haven't seen those, this is a steel carrier washer with a rubber section that's bonded into the centre of it. Doughty seals, they come by various names. I still call them Doughty seals because they were originally from a company called Doughty, I've no doubt. They're fantastic things. They don't expand when you compress them because they've got that metal around the outside. If you over tighten an O-ring, it will squeeze out. Doughty seals are designed so that that can't happen. They also don't tend to deteriorate so rapidly with temperature and so on, so you can carry on using the same Doughty seal for many years. They work great. That's all in. And I'll turn the pump round and we get to the top section. So the things we took off. We had the exhaust port, which gets a new O-ring, screws into there, hand tight. The O-ring's taking up the seal, hand tight. There are flats on here there for taking it off when it's contaminated into position and solid. Definitely don't need to use that to do it up. Same with the oil fill port. I'm going to give that a couple of turns just so I know it's going to go in there. I'm not going to bother tightening that up because obviously it's going to need to come off and fill the pump with oil. And then we're back to the adapter plate section here, which is where the gas ballast came off. The gas ballast assembly, I hope you will remember removing ball bearing. And we had a little struggle to get that ball bearing to come out. I just had a bit of a struggle picking it up out the bottom of that pot. But that ball bearing drops down into that hole. Got a new spring that drops in on top of it. And then we have the gas ballast knob. Now we've got a new piece of foam that sits around the outside there. Just make sure that that tucks into the recess in the knob. It'll seat itself obviously, but it needs to be just convinced to go into there so it doesn't splay out. And then this gets an O-ring, so that when it's wound down shut, that O-ring is actually making the seal. So the O-ring needs to sit down inside the foam, and then that whole section can be put on here. The springs in here are very long, so the spring will be under tension long before you get the threads in. You want to try, well, you want to succeed in getting that to go down straight, so the spring is not bent over when you start to wind it onto the threads. And many turns later, that's now installed. Never want to put a lot of pressure onto this. The shut position is easily reached. You don't need to put a lot of pressure on there, or you'll find it's impossible to get it undone again afterwards. So that leaves the inlet. The inlet strainer, which we took out, that's been thoroughly cleaned. That drops back in. And then there should be a retaining circlip that sits over that. Which I've forgotten to wash. But it's a clean part anyway, so it's not a major issue. Back to my circlip pliers, and again, these can be tricky to install, so patience. Didn't I just say these can be tricky to install? Fortunately, I found it again. So squeeze it down with the pliers and lower it into position. There's no actual slot for this to sit in. It just sits down as low as it can. That retains the strainer. And then on top of that we get the intake port, which again gets a new O-ring. Sits in there. And again, the flats are for taking it off, not for putting it on. That just wants to be nipped up by hand, and the new O-ring under there is going to give it a nice seal anyway. So that end is all done. And we really are getting close to finishing this pump off. So before the motor goes on, we've got the felt pad to go in there. So you don't need to be bothered with oil leaks for quite a while until that's soaked up. And then the red plastic cover sits over that to hold it in place. With a couple of screws to keep that all sitting there. And then we can put the motor on, so I'll go and get that. So we've still got the side flashes to fit. I'm not going to do now, obviously I've still got the grub screw to go in. With the coupling back on, give this a final turn manually by just pushing the fan round Make sure it goes around a full rotation, no binding or anything. Don't want to put the full power of the motor into it if there's anything that doesn't feel right by hand. But I think that's good. So we can put oil into the pump. The remaining oil from the jug that I used in assembly can go straight in there. You can see it coming up the sight glass. And that was just exactly the perfect amount. It's now sitting right on the maximum mark. At this point I can nip that up by hand, tighten it off, make sure the inlet is on solidly, and that's ready to go across the test bench where it will be put on to test. And while I'm over there I'll fit the grub screw and the side panels. So here on the test bench, this is the E2M2 and it's operating well. It started up very well. It's now at full vacuum, 1 times 10 to the -3. I've tightened up the grub screw and I've fitted one side flash. One thing to mention is when you fit these, don't over tighten them, because over time they're plastic and they become very brittle and they tend to crack apart like that. So I'll need to go and find a replacement for that. The pump is ticking, tapping a little bit at the moment. I don't think it's the motor. I did run that off the pump to check for noise and didn't have any problems. Likewise, I don't think it's the coupling, because the coupling turns freely by hand and doesn't catch at any point. It sounds to me like a bit of blade slap, which is what you get with the pump when it's down at deep vacuum and the blades are just moving about. Because it's all been apart and been cleaned, I'm going to let it run for a few hours and then reassess it. So yes, there is a little bit of a tapping noise which shouldn't be there, but generally speaking this pump's turned out very well.